Thanks everyone for coming to this webinar today. And I'm going to be talking about the non-energy benefits of energy efficiency. And so I'm just going to talk a bit about it, maybe for 10, 15 minutes, and then I'll take time for questions afterwards. So firstly, a project that just relies on the energy savings alone may not have may have an unacceptably long payback period. And but once you start to consider the non-energy benefits, it becomes a much more attractive investment, and your client's probably more likely to proceed with the upgrade. So broadly, there's three ways of classifying these benefits. Very, very broadly, you could make more categories if you wanted, but I've just divided them into three. Uh, so one of them is improved productivity. I use the word productivity quite broadly there. The second one is additional cost savings that you get. And the third one is increased asset value. So I'll give you examples of each, and then I'll talk a bit about how to quantify these benefits. Okay, so let's give an example of improved productivity, and one that I came across quite early when I was working in energy efficiency, because I was doing a lot of work with schools, was that school results, student marks actually improve in classrooms where there's an abundance of natural light, and they're less reliant on artificial light. There's more daylight coming to the classroom. And now one of the challenges of getting more light in the classroom is you don't want to get extra heat if you're in the tropics, or extra cold if you're in a cold climate. Now, clerestory windows, so these are windows that are elevated up high, kind of normally there'll be a roof and then there'll be a clerestory window and then a roof sloping down. These are actually quite commonly used in classrooms here in my state of Victoria. And if you get the orientation right, so there's a bit of an eave overhang there, they're actually fantastic because you get really good penetration of daylight deep into the room. And in winter, when the sun is low, it's facing the right way, you get good winter sun in, which warms the classroom. And in summer, well, the sun is higher and it hits the eaves and doesn't come into the classroom. So you don't get the heat gain in summer. You do get the heat gain in winter, which is fantastic. And you get a lot better light in the classroom due to these clustering windows. In fact, I liked it so much that when I did a house extension, 15 years ago now, 16 years ago, I actually put clustering windows in my house. And now I have this room in my house, which is really wonderful in winter because the great light that comes in, and it still gets and sunlight coming directly in winter. And in summer, we still get a lot of light. It's really nice, but we're not getting the heat gain because the eaves stop the sun coming in. Now, this is actually an example of passive design, and it's a little bit hard to retrofit. But if you're involved in designing a new building, it's a great time to put it in. And if you're new to energy efficiency, I'd advise learning a bit more about this. And on the Sustainability Education Academy, we actually have a whole series of 6 courses on related to passive design. And then we have it's on energy efficient building envelope design. There's also a certification around that. So that's just an example of improved productivity. Another example of improved productivity is where equipment upgrades lead to less downtime due to equipment failure or maintenance. Let's look at lighting upgrade, how this can improve productivity. So typically, and I still see these lights around, we have got legacy HID or high intensity discharge lighting still in use in many places. This could be high pressure sodium, metal halide, or even mercury vapor, which is really energy inefficient. So these lights actually basically excite a gas. Fluorescents do as well, actually, but these lights typically have a very long warm-up time. So if the power goes out, even for a very short period, just for half a second, the lights go out. When the power comes back on, it takes them 10 to 15 minutes to get up to full brightness. And in a facility, say a warehouse, which is relying on these lights, there's even a short power outage. People can't work probably for about 5 to 10 minutes and after the power's come back on because it's just not bright enough. The lights take a long time to get up to full brightness and are not very bright at all when the power is reconnected. So this is a way of if you're in an area where there's power outages are reasonably common, and you've got these old lights, well, just switching to LED lights, which have instant full brightness when the power returns, will give you very good productivity improvements in terms of people can go straight back to work. Um, Another example of productivity is, let's say have a you're a landlord in an office building, and it's a large office building. You've got multiple tenants. Um, if you upgraded to LED from say fluorescent lighting, and you put in addressable LEDs, they'll be a bit more expensive. But the beauty of an addressable LED is then you can change the floor plan, and there's no rewiring of switches. You can just program in the new switch positions to control the different lights. Um, so it's a way, I guess, of aiding in productivity and retrofits. But then also, you could also potentially, and I'm going to talk about this later, increase the asset value and increase your rental by putting in a high-end LED, perhaps with some colored LEDs if it's in a retail space, or LEDs that can change colors. And you can create a real wow factor, which would attract tenants and also increase the rental, in addition to giving energy savings. So there's multiple benefits there. But I'm kind of bundling this in the productivity area. Now, a second area is additional cost savings. So you're probably familiar with these, but these typically can come from decreased maintenance requirements. So, for example, LED lights will typically last much longer than the legacy lighting they replace. They're replacing fluorescent, they might last 4 times as long. They're replacing compact fluorescent, they might last 5 or 6 times as long. If they're replacing HID lighting like metal halide or high pressure sodium, well, it depends on the technology, could last 2 to 3 times as long. Um, so that means that you don't have that maintenance expense. On the other hand, perhaps it's not quite that true, because often when an LED fails, you have to replace the whole fixture. Um, so perhaps you've got a large expense down later down the track. But so let's then look at an even better example, which would be when you're when you're reducing the hours of operation of equipment. Now, this is a very, very common energy efficiency measure, and it's applicable almost everywhere. There's often in almost any building, there's equipment left running that shouldn't be. So there's two ways of reducing that runtime. One is by behavior change, which can give short-term savings, but those savings may be lost over time. You need to keep working on the behavior change program. We can start to use some technology like sensors and run-out timers and things like that that can reliably reduce run hours. Now, then the advantage of reduced run hours is straight away, well, if you're running less hours per year, you've got less wear and tear on the equipment, and therefore you've got less maintenance costs, and you're extending the asset life. So it's quite a good benefit there, in that you're saving energy and you're saving maintenance costs at the same time. Now, this leads to the third one, which can actually give really, really surprisingly large benefits. And this is the increased asset valuation, particularly in buildings that are tenanted. So, and there's many case studies and examples of this. And what you need to do is do a Google search on this. And I'm going to try to quantify some of these benefits now, particularly the asset valuation. So, once you've identified what the benefit is, in order to quantify it, just do some research and ask some questions to help you quantify the benefit. So, for example, if there's some unreliable equipment that keeps failing, and that you can ask some questions and find out, well, each time it fails, we've got 10 people working in that area and they can't work. And then you ask, well, how long does a typical breakdown? Oh, they might have to wait a couple of hours. And how often does it fail? Once a month. So therefore, you've got 10 people doing nothing for 2 hours once a month, which over a year is what, 24? That's 240 person hours a year, which is actually over 1 month's salary for one person, because average person works 2,000 hours a year. So that's actually quite a large expense. And then the non-energy savings, however, could be even more than that, because perhaps this particular business, due to those equipment failures, is struggling to keep clients and it's struggling to keep clients because it's got delays in shipping out its products. So therefore, if an energy efficiency upgrade replace that old equipment with something which is much more reliable, you're going to get some benefits there. So you can see that just by asking questions, you can start to zoom in and quantify the benefit. And any good approach with energy efficiency is you try to not go in as the expert consultant, you go in as the partner, and you're partnering with the person who contracted you, because obviously the person who contracted you wants you to succeed. You want to succeed. So you develop a close partnering relationship where you're kind of working together to solve the problem. And then if you manage to establish that kind of rapport with a person, they'll be on your side helping you come up with additional benefits from the energy efficiency upgrade. And then you don't have to be too shy with the questions. Just ask the questions and you'll learn and you'll be able to quantify these benefits. Now, you could also look to industry reports or studies and using terms such as what are the benefits of daylighting in schools, like the example I gave, or what's the increase in asset value due to improved energy efficiency of office buildings. Now, if we look at tenanted buildings, let's look at the quantification of this because it's really interesting. Let's say one of your clients owns an office building and there's tenants in this office building. And often, if you can increase the rental from that office building, there's actually a multiplier that applies to that, which will increase the asset value. So let's say I've got an office building and I've approached the owner about an energy efficiency upgrade. And they've agreed, but I've not sold so much on the energy efficiency benefits. I've sold it on the increased rental value that you're going to get by you're going to be able to charge higher rentals after the upgrade, and you're going to get increased asset value. So, for example, we're not just focusing on the energy savings, we're also focusing on the appearance of the building. So I could be very careful in selecting good-looking LEDs. If I'm doing work on the air conditioning system, I could perhaps be replacing those, very square prismatic diffusers with a swirl diffuser, which looks much better, for example. And by doing that and kind of having a fit out, in addition to the energy efficiency measures, perhaps some painting and other things to improve the fit out of the building, but the energy efficiency kind of at the heart of it, you could ask more rental. So let's say you can achieve an extra $30 per square metre per year from energy efficiency upgrade in rental returns. Due to this high quality lighting, a much quieter air conditioning system, better looking diffusers, and other aspects, modernising the lifts and elevators, and of course getting energy efficient at the same time. That could translate, let's say, using a multiplier of 10 to an increased asset value of $300 per square metre. If you're saving $30 per square metre per year in increased rent, or you're getting $30 per square metre per year in increased rental. And so for a 10,000 square metre office building, that's a $3 million increase in asset value. It's probably worth a lot more than the energy savings, and it could possibly reduce the payback on the energy efficiency upgrades to maybe less than 2 years, maybe even less than a year. Now, this multiplier that I've used in terms of the asset value is called the gross rent multiplier. And in a higher demand market, say in a CBD area in a building, in a city, a CBD area, that will typically be, say, 10 or higher. In a less competitive area or emerging markets, that GRM multiplier might be 4 to 8. But you can see that this is such a great multiplier of the value of energy efficiency, and something that previously may have had a payback of perhaps 8 or even 10 years, a lot, which is not many people are going to go for that. You could perhaps, using this increased asset value, increase the overall payback down to perhaps 2 years, and they go for it. So if you just look at the energy savings alone, payback's 8 years, maybe 10 years. You look at all the other benefits and the increase in asset value, say in a tenanted building, and then that payback may drop for 2 years and your project goes ahead. So with that, that's the end of my brief presentation.